Every day, humans and animals interact with each other in different settings. Think about the pets in your home, wildlife that visit your backyard, and even animals at the zoo. How many of you have been to the zoo and touched the animals or watched the zookeepers feed the big cats during a demonstration? What is not visible are the microbial communities that live in the air, on the skin and fur, and in the mouths and stomachs of people and animals. These communities, mostly made up of bacteria, are called the microbiome and can be shared between people and animals. Research has shown that the microbiome in people living in the same household, and even the pets in that household, are similar. This is likely because bacteria are being shared during close interactions. But a zookeeper isn't sleeping with the tigers like they might be with their pet dogs, or getting licked on the face by monkeys. So how might this happen in zoo settings? Well, this is exactly the question that my research aims to answer. Does bacterial sharing happen in zoos? How does it happen? And what are the impacts? This research is important because more than 2/3 of infectious diseases are caused by microbes that can be shared between people and animals. So working with zoos in the Southwest, I plan to collect poop samples and nose and mouth swabs from big cats, primates, bears, and canines, as well as 2 groups of zoo staff. The first group will be zoo staff that have known levels of animal contact, zookeepers and veterinarians. The second group will be zoo staff that have no animal contact. Laboratory testing of the samples will give us information on the composition of the microbiome. What types of bacteria might we see in those samples? And what is the ratio of each type of bacteria relative to the other types? Now, I expect to find similarities in the microbiome of animals that are of the same species and those with similar diets. But I also expect to find similarities in the microbiome of zoo staff that have levels of animal contact and the animals that they have contact with. Zoo staff with no animal contact will have more differences in their microbiome. Through this research, we can gain understanding about the bacteria important for human and animal health and uncover risk factors that might lead to bacterial sharing in zoo settings. I further hope that this work will help guide the development of best practices to reduce those risks, promote long-term animal health, and continue to make zoos places that we all love to go and visit. Thank you.